So today I want to talk about investigating slope graphs, and when we're talking about slope graphs and slope functions, or f prime graphs, this f with a little comma here reads as f prime, we're talking about plotting the motion of an object as velocity versus time. So we have two graphs here. We have f of x and f prime of x, and I just kind of want to look at this and make some comparisons. So the first thing that we can notice here is that f of x is concave down from negative infinity to 1.8, which is about here-ish, right? And what's going on here? Well, from negative infinity to 1.8, this is decreasing. So f of x is concave down and f prime of x is decreasing. And I'm not going to put in that the points are the same. Well, I guess I can. From negative infinity to 1.8. And it's concave up from here, 1.8 to infinity. And we can see from 1.8 to infinity, this f prime of x is increasing from 1.8 to infinity. At x equals 1.8, we have a point of inflection. This right here, this is our point of inflection, which I'm just going to call POI, point of inflection. And at our point of inflection, f prime of x has a relative minimum, actually. Right here, that's 1.8. There's our at x equals 1.8. I got it smudged there, but hopefully you can still read. F of x is increasing from negative infinity to negative 0.9, and again from 4.2 to infinity, right? It's increasing. And what's happening there? Well, from negative infinity to 0.9 and from 4.2 to infinity, f prime of x is positive, meaning that it's actually above the x-axis, right? So it's positive from negative infinity to negative 0.9, and again from 4.2 to infinity. Well, it's decreasing from negative 0.9 to 4.2. Here it's decreasing. And what's happening to f prime of x then? Well, there it's actually negative. So hopefully you're starting to see a little bit of the pattern that we've got going on here as to what's going to happen to our graphs of our function and then in relation to our derivative. Well, at negative 0.9 we have a relative maximum. I'm just going to do these last two together. And at 4.2 we have a relative minimum. So here's that negative 0.9, x equals negative 0.9, and here's that x equals 4.2, right? We have a relative maximum, a relative minimum. Well, what's happening at those points here? Those are actually our zeros, right? We have zeros. It's a solution to the graph. 0 at x equals negative 0.9 and x equals 4.2. So let's see if we can use some of this information to actually draw a graph here. We're given the function y equals g of x, and we want to draw the graph y equals g prime of x. So just take a moment to look at that and think about how you might actually draw that and what it would look like for you. All right, hopefully you took a moment there and kind of thought through some things. Well, I'm going to just draw a number line down here. You don't really need a number line that badly, but it kind of helps to identify some things. Looks like here we have a point of inflection at, I don't know what that is, maybe like 0.8, okay? 0.8. Looks like here we've got, this is about 3.3. Here, this is about negative 2. And, you know, these points are going to be pretty important to us. So when f of x is decreasing, or g of x, right? We've got g of x here. When it's decreasing, then that means that g prime of x, so I'm just going to put an arrow down to show that it's decreasing, then g prime of x is going to be negative, right? So from negative infinity to negative 2, my g prime of x should be negative. Whoop, there we go. Then from negative 2, and I'll just put a negative 2 here, to 3.3, g of x is actually increasing. So it should be positive there, right? So until 3.3, I should have positive things happening. I'm not going to do anything quite yet to draw that, because I know that my point of inflection here is also important. This point of inflection, as we saw earlier, we go back up here, our point of inflection became a relative minimum. Well, now my point of inflection is actually becoming a relative maximum, because obviously if this is decreasing, now it's got to have a relative maximum up here. And something you may have noticed, but will become evident in time, here you have a cubic function, right? So your derivative is always going to be the next one down. So here you're going to have a quadratic function. This is going to be an x cubed. This is going to be an x squared, right? If this was x squared, the derivative of this would then be x, right? So whatever your derivative is will be 1 degree less than what the actual function is. So we know, even before we finish drawing this, that we should have a parabola by the end of it. So my point of inflection is going to be my relative maximum at 0.8. I put that here, but 0.8, looks like it's going to be like 2 something, I don't know, something like that. And then I said till 3.3 was when I was positive, so something kind of like that. And then from 3.3 till infinity, I'm decreasing, so that's when that will be negative, right? This is decreasing again, so decreasing, and here it's positive, 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 positive. So hopefully that kind of makes sense to you. Now to find actually that maximum at 0.8, we could kind of just plug it in, but I just want to just draw this to see how it looks, but that looks pretty accurate there, right? So let's move on and look at some other graphs and kind of talk about their relationship to one another. So here we've got, can you see all of this in the frame? Yes, I think you can. Here we've got f of x, f prime of x, f double prime of x. This might be hard to read, but it is f double prime of x. So f of x looks like it's increasing from -3 to infinity. It's concave down, which means that like it's arcing down, right? Concave down. And the slopes are positive. The slopes are positive, right? If I was drawing tangent lines here along this graph, I would have positive slopes of those. Now, f prime of x, if we look at this, f prime of x is positive, right? It's above 0. It's greater than 0. It's decreasing from -3 to infinity. And the slopes are actually negative here, right? It's decreasing from -3 to infinity, and if I drew a bunch of tangent lines there, my slopes of those tangent lines would be negative. Now let's look at f double prime of x. Here, it's negative, right? F double prime of x is negative. But it's actually increasing from -3 to infinity. And if, again, if I drew my slopes, these would be positive. Just a good way to kind of see the relationship between these. Let's look at another set. Here we have an absolute value function, f of x, right? We've got an f of, it decreases from -infinity to 2, and then increases from 2 to infinity, right? And our slopes here, you know, you'd have some negative slopes, some positive slopes. Here you'd have no slope because that's a cusp, so you can't have a slope there. But here is our derivative there, our f prime of x. Well, from f prime of x is less than 0 from -infinity to 2 and constant, right? And constant. How am I going to write that? And constant. Constant. You can see that. It's just a straight line. But f prime of x is greater than 0 from 2 to infinity. And still constant. I'm going to just write con, right? Right? So that cusp there, you saw there's no derivative there, and now we can see that. This isn't continuous. So there's no derivative there. And finally, if we look at f double prime of x is just equal to 0, except x cannot equal 2, right? And that's where we had that hole before. Well, now we've still got a hole there, right? So those constants, slope of a constant is just 0, but because there is no derivative here, we have that hole. Finally, let's look at one last one. We have this beautiful equation. I didn't draw it very well, but it increases from negative infinity to negative 2.5, and then, so right here, this is that negative 2.5, and then again from 0 to 2.5, right? Beautiful. And it decreases from, looks like 2.5 to 0, and then again, I keep smudging this, from 2.5, oh, this should be a negative 2.5, excuse me, to infinity, right? And then at negative 1, 1, what do we have going on there? Well, we've got these points of inflection here. I'll ignore what I said about negative 1, 1. All right, well, let's look at our f prime of x graph here. F prime of x is greater than 0 when f of x increases, right? And that should be the pattern you're kind of seeing now. And f prime of x is less than 0 when f of x decreases. I spelled decreases wrong. And f prime of x is equal to 0 at the maximum and minimum points of f of x, right? So at 0, 0, 0, those were our maximum and minimum points here, yes? Finally, we'll look at our f double prime of x. Well, f double prime of x, f double prime of x is equal to 0 when f prime of x is equal to 0 at those minimum and maximums, right? And f double prime of x is equal to 0, 0, 0, 0, where f prime of x has a point of inflection, right? So our point of inflection here was 0. This actually, it's equal to 0 there, right? Because that's going to be our relative maximum now. And then these relative minimums, minimum and maximum, became our zeros there. So hopefully you can kind of see a little bit the pattern here, and we'll do an activity together where we can kind of match some of these up and kind of get a better idea. But hopefully you understand this. Any questions you have, please put in the comments of the YouTube video, and I look forward to seeing you in class. Bye!